So thinking through those same exact steps for these equations right here, multiple variables. So you might use this if you were in a science class where you had an experiment you were going to repeat a bunch of times. And rather than solving every single time you ran the experiment, you could just adjust the equation so that you could just plug it in every time. So in this one, if I wanted to solve it for the variable s, then just like we were learning up there with numbers, I would want s by himself. 4 times s would need to cancel that 4 by dividing. The only difference is instead of another number right here, we just have the letter p, which is also a mystery. Since he's a mystery, that's as far as I can go. The answer is p over 4. S all by himself would be equal to p over 4. And that's it. This one, if I wanted to solve it for the t right here, it's being multiplied by a p and an r. We undo multiplication with division. So if I divide by that p and that r to make them cancel, then this right here is an I. It's a little bit hard to read. I over p and r, both on the bottom, would be equal to t. So if I needed to solve it for t, I would need to take whatever I found for r and divide it by the p and divide it by the r. I think I said r, I meant I. Okay, now this one, if they wanted c all by himself, all alone over here on this side of the equal sign, then I have it added to a and b. So I want to cancel these additions by doing a subtraction. This positive a would cancel with a negative a. This positive b would cancel with the negative b. Same thing to both sides. So p minus a minus b would be equal to that c all by himself. Now here's a two-step. We've got the w, and it's just like these problems we were doing right here. So remember that I needed to move the one away first that was the constant, that was not attached to the variable, and then last do the multiplication and divide. So it's that same idea. Here's my w, this is the variable that I want to isolate. So first I'm going to move, well, it's not a constant, I'm going to move the one that's not attached to it, the one that's added or subtracted to the term with the w. So this right here, it's not 21, it's actually 2L. Needs to get moved over out of the way, subtracted to the left there with the p. So again, the only difference is that I can't combine them. So I write it out just like that, p minus 2L. So these are actually a little bit easier because you don't even have to work the numbers, you just write it out. Now this last step, when I divide by the 2 to get w by himself, I can do one of two things. I could put the whole thing over 2. That's fine, that is a correct answer. But I personally prefer to break it up. If I needed to divide it by 2 and I wasn't able to combine these two terms, then I like to divide each one individually, one at a time by the 2, which gives me a slightly different looking answer, but it's really the same overall. Let's do this really quick so I have room. So one form of the answer would look like this right here as p minus 2L over 2, but then the other one would look like this, p over 2 minus L. Those would cancel. Both of these answers are true and valid and acceptable and give you full credit. But the reason that I like this one better is because it really helps you when we get into the graphing problems like this. So one other really common place where we use solving for a variable is for graphing. Because our graphing calculator that's so awesome and handy only has a button for y equals. So that means if I had an equation in any other form, I'd have to tweak it so that I had y equals all by himself. So to do that, I would do these same exact steps. So first I'd move away the thing that did not have the y. Be careful not to combine unlike terms. That is not a 4, it's just 6 minus 2x and the last step of dividing by 3. Like I said, you could put the whole thing over 3. That is true. But it makes life just a little bit easier to break it apart when we get into that graphing section. It helps us identify important features of the graph. So then I can break it down and reduce things a little bit more easily. 6 divided by 3 is 2. This one is a fraction that does not reduce, so I just leave it just like that. 2x over 3. And that's it. Let's try it one more time. So this one, if I wanted to solve it for the y right here, first I move the term that doesn't have a y. Be careful not to lose that negative. It's tempting. Now right here in this last step, I'm dividing by the ninja number. I did not have it all by himself just yet because he had the negative. I need to cancel that negative. So I can do that by dividing by a -1. So I divide everyone by a -1. Then I have y all by himself, positive y, not negative y. Now you can see how this one's much easier to reduce. If I had it all over 1, I'd have to kind of think about it. But 14 over -1 is -14. -3 over -1 is +3. And there's our cleaned up equation. Okay, handful of word problems here, don't panic. Okay, it just wants us to set them up and then solve. So these are the relatively easy word problems because it tells you the equation just in symbols, or in words instead of symbols. So we just have to convert. So it says what number should be added to 68 to get a sum of 45? Okay, so twice it indicates that we're going to be doing an operation of addition. The what number is generally going to be our variable. I always like traditional x. What number should be added to 68 to get the sum, the result of addition, of 45? So this is a relatively easy problem after some of those crazy ones we just worked. Remember, that's usually true of the word problems. They're relatively easy. You just have to get them set up. So that's going to give me the final number answer. So I lost my place there, of -23. -23 added to 68 would make 45. Okay, 36 is 4 more than twice a number. 36 is almost always translates to an equal sign. 4 more than, that's going up, 4 plus twice a number. Twice is always going to be a 2 times. Okay, sometimes people think it's an exponent. There's no kind of colloquial way to say this. There's no casual way to say an exponent. You pretty much have to say x squared or x to the power of 2. So there's no just fun way. So if you ever see double, twice, triple, things like that, it's always multiplication, never exponents. Plus, in this whole section, we haven't talked about exponents. And remember, the word problems are going to be doing what you were just doing. So if you were thinking exponents, you'd say, I don't know how to do that. There must be multiplication. Here's that 2-step. Now remember, it's never about left or right. It's about getting variable by himself. So the first thing I need to do is get this non-x term out of the way. So I move the 4, gives me 32. And then I cut it in half for the final answer of 16. Okay, 16 doubled, 32, plus 4 is 36. We're making good progress, guys. Just another couple of word problems here. Now, this one has one of those sneaky words. Remember, from and than. Those were the sneaky words. From and than. Always watch out for those guys. They make things be backwards. 5 less than a number. So that means there's a subtraction happening at the back. 5 less than a number. Okay, the number minus 5 is equal to 13 decreased by the number. No sneaky words. 13 decreased by the number. 13 minus the number. Nothing sneaky to make this one backwards. From and than are pretty much the only ways to make it be backwards. 5 less than the number, backwards. 13 decreased by the number. Okay, now this is one of those with a variable on both sides, so I want to get them together. Okay, here's that ninja number. If I had a negative 1x, I would cancel it by adding a 1x. Okay, this one is really a 1 plus 1 is 2 x's. Careful, not x squared, we're not multiplying. And then we can add the 5 over. And we're going to run out of room here. I'm going to have to take it to the next line. That would leave me the 2x all by himself equal to 5 plus 13 is 20. Nope, sorry. Getting ahead of myself. 18. And then last dividing to see that the x would be a 9. 5 less than 9 is 4, which is equal to, wait, hang on. 5 less than, see I did it. 5 less than a number. 9 minus 5. 5 less than 9 is 4. Hang on, no. Yeah, okay, get myself confused. 5 less than 9 is 4, which is equal to 13 decreased by 9, which is 4. There we go, sorry. So trying to check my work and I confused myself. Okay, so 4 is not the answer. 4 was me checking the work. 9 is the number that makes that happen. Okay, this one we've got a shape, but don't panic, just kind of draw things out, think through it. We've got a rectangular parking lot. It's supposed to have a perimeter of 450 yards. My rectangle got kind of slanty there. Okay, now remember, perimeter is going around the outside, like if you were building a fence. So if they needed a perimeter of 450 yards, and they said the width has to be 90 yards, okay, then that means if it's a rectangle, this is also going to be 90 yards. That means this is the mystery here. So we would need a length on the left and a length on the right. So let's see what that would work out to be. So to be a perimeter, I would have to take the 4 sides added together. And it says that when I did that, I should get an answer of 450. Okay, you may also remember the formula 2w plus 2l equals perimeter. That's also cool, but if you just remember adding these up, you're going to come to the same place where I had 2 of the x's and 2 of the 90s. So I can finally solve my little equation. And even if you were just thinking through it and not writing these symbols down, you would think the same thing. You'd say, okay, if it's a total of 450, I'd take out this side and take off this side, which would leave me with, right here, lost my place, 270. And then since I knew there was an x here and an x there, I'd have to cut it in half, which gives me 135. Okay, and you could add those 4 sides up just one more time to make sure they're 450, and it would work itself out. Okay, a couple more here. The total cost of producing X items can be found using this formula right here, where A is the cost per item, K is the fixed cost, that would be like utilities, rent, that's always the same no matter how many of them you make. So it says you can find the cost of producing 30 items if each cost $15 and the fixed cost, the rent and utilities and such, were $580. We're just going to kind of piece this together. So we're going to find the total cost C when I knew that I was producing 30 items. A was the cost per item, K was the fixed cost, and X was the items. Okay, that means X is the items, which I just said was 30. 15 was the cost per item. They said that was A. And then K was the fixed cost, 580. So this one, I don't even need any algebra. I just put it together. $15 an item for 30 items would be $450, plus the $580 that they have to spend no matter what, gives me a total cost of $1,030. Okay, one more using that same formula. It says if you knew that the total cost was $1,097.50 to produce 80 dolls, and it costs $9.50 for each one of those 80 dolls. Let's work our way backwards. This time we know the total cost. We know the cost per item again, and we know the number of items we're making. So the only thing we're missing is the fixed cost K. Okay, so let's multiply these together. Let's see how much we're spending on the dolls. We're spending $760 just making the dolls, which means the fixed cost must have been $760 less than the total cost. So the fixed cost were $337.50.